Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice in using StatCrunch for nonlinear regression analysis. Let's get started. So in the previous mini lecture, we kind of went over this sort of a theoretical overview of the process that we're going to use to solve nonlinear regression problems in StatCrunch. In this mini lecture, I want to focus on using an example problem to demonstrate how that process is actually used. So here our example problem involves bacteria growth. There was a carefully controlled experiment in which bacteria were allowed to grow for a week. And here we've got some data that, basically we count the number of bacteria that we have at the end of each day. So we've got 7 data points here. And the questions we're asked are, first, what does a scatter plot look like? 2, what mathematical model best fits the given date? And 3, how many bacteria can we expect to see on day 8 at the 5% significance level? So first, what we're going to do to make the model in StatCrunch is we need to know which of those generic model types we're going to make. And that's where we look at the model table there to know which one we're going to make. Now, you can actually access a free copy of the tables that you're going to need to use StatCrunch. You can go to, you can get it from, here at AspireMountainAcademy.com. There on the website, you can get it there. You can just basically download it and print it out, and there it will be for you to use. So here's what the actual, model table looks like. And we look through the list here to figure out, okay, so let's see, we're dealing with bacteria growth. So we look through the list here and see, okay, where does it say we're growing bacteria? And we see the application right here in the middle of the table. So that tells us we want to make an exponential model. So we don't need to make all the different model types. We know exactly which one we need to make. So next, now that we know what model we need to make, we need to prepare to make that model. And we do that by going to Stat, Regression, Simple Linear. And then we look at our data transformation table and look for the section that corresponds with exponential models. So we look at that row for exponential models. I've actually truncated the table here for purposes of the demonstration. But you can see we've got the different sections here. General form, this is the option we take in StatCrunch to get our model. Here's what we put in the options window, and here's what we use to get the results window data to give us the answers we're looking for. So first we're going to make, simple linear model by going to Stat, Regression, Simple Linear. Now, we can actually transform the data in the options window to turn it into an exponential model. So here in the options window, notice the area down here for transformations. Okay, so we indicate where our data is at, there at the top, and then down here below where it says transformation. Okay, once we've selected our data, we can come down here and select the transformations that we need to put in the data. Notice how it's listed here. So X, it says none, so we just leave that alone. And then natural log of y for y, so we're going to take the natural logarithm and select that from the drop-down menu for y. Notice we also have this box checked for use original units in the graphs. Okay, so we want to make sure that box is checked, and there's a reason why we want to check that box. Okay, we'll get into that in a moment. But at this point, we just press compute. We get our results window. There on the second page of the results is the scatter plot, and we should see a regression line that appears to fit the data. Okay, but if you don't check that box for use original units in the graph, you're going to see something very different. Okay, let's take a look at what we actually see. So, if I check the box, this is what comes out. This is what we should see. This is what we want to see. A model that forms according to that pattern for the exponential model. If we don't check the box, here's what comes out. Remember, we're using the simple linear functionality in StatCrunch to get our model. So if you don't check that box, it's going to assume you want a simple linear model. And so, yeah, you can judge the model fit here, but, you won't see the true pattern that your data points are showing you on the scatter plot. That is hidden. That's obscured. So make sure you check that box there in the data transformation section so that you can get the true pattern of your data points when you look at your scatter plot. Okay, now we're ready to actually make the model. So when we hit compute, here's the results that come out. And we're looking at an exponential regression equation. Notice that the form for our equation up here is in the linear form because we're using the simple linear functionality. So we've got to transform these coefficients here. We can't just take these and put these in our answer field because that's going to give us the wrong answer. We need something that's in this form because this is the general form for the exponential model. So to get that general form, we need the A and the B, and that's where this last column in our data transformation table is helpful. It tells us how to get the A and the B from the numbers that are listed here in the parameter estimates table there in StatCrunch. So we look at that section. It tells us what we need to do, and we just follow those instructions. So the first one says that A equals E raised to the intercept power. So we're going to take that equation there. We're going to find the intercept value up here in the parameter estimates table, and then we're going to plug that value back down here into our equation. So we calculate that out. E raised to the 2.6431819 power. That gives us 14.06. And that's the number we want to stick into our answer field for the coefficient. We do the same thing for the slope, because notice in the results window for the column for the data transformation table, it gives us that equation for B. So we do the same thing there. Take that slope value from our parameter estimates table, stick that there in for the slope, and we calculate that out, and we get 1.89. So then we plug the A and the B into the general form, and that gives us the regression equation that we're looking for. So our regression equation is y equals 14.06 multiplied by 1.89 raised to the x power. Notice that if you put in the parameter estimates table for those spaces in your answer fields, you're not going to get the right answer. You're going to get the wrong answer. So you've got to use that data transformation table to get the right answers out when you're using the exponential and when you're using the power function. Now, for the other options, it'll tell you there in that same column what you use, but typically you're just grabbing the numbers and going with them. Now we can easily make a prediction once we have the model made. So go back to the options window there in StatCrunch, and we can enter an X value for a prediction. Notice the prediction value here, there towards the kind of the center of the graphic, and make sure that you provide a predictor value in the right format as well as the appropriate prediction level. So it wanted 5% significance level, so that's the same thing as a 95% prediction level. And we can then, once we put that in, we can just punch that out with compute. And in the results window down there at the bottom, we get a predicted value. So StatCrunch will actually calculate this out for you, but you have to put in, again, the right numbers in that prediction of Y area. Okay. You can also get a prediction interval if you ever need it. It's there on the end of that same row there under predicted values. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.